Reusable systems for transportation in space are definitely on the rise, and everything is moving super fast. Today, we get to talk about how space can be accessible to all, and the advantages of working from Europe.
We went to Munich to meet with Hélène Huby, CEO of the Exploration Company, a brand new player on the space market with a mission to democratize space exploration. My name is Marcus Pettersson.
My name is Susanna Levenhaupt.
And this is Have We Gone to Mars Yet?
The Exploration Company was founded in the summer of 2021 when a team of employees at Airbus and the Ariane group decided to go on a mission of their own. Their goal is to provide affordable ways for anyone to access space.
And the timing seemed perfect. Since they started, the Exploration Company has reached every target along the way towards their first launch that is expected late 2024.
And talking to their CEO, Hélène Huby, really gives you a hint about the speed it's all moving in. It's a lot to take in, but let's start by letting her explain what the Exploration Company is exactly.
Well, basically we're building spaceships. So we focus on space-to-space transportation, and we're doing that for cargo, and then the end goal is to do that for humans. What we do, which is kind of very new, is that we're going to reuse the same techno bricks, the same design also to carry first cargo and then people to moon, and then bring that back. We don't build a rocket. We'll see what the future brings, but we are currently 300% focused on building the spaceship. So you want to think about Dragon, for example, right? Or the upper stage of Starship. So that's where our focus is. Because, currently you have more than, to my knowledge, 150 projects of rockets in the world. So if you want to build a rocket, you really need to come with something new. And I don't see a lot of new things you can really serve. But when you look to space transportation, it's still super expensive.
What do you mean by space to space?
If you want to go to a space station, for example, first you need to go to orbit, right? So you'll take a rocket. But then you need to go from where the rocket launches you in the orbit to the space station. And that's done by another vehicle. That can be like a reusable upper stage, or that can be a very specific vehicle. Same for the moon. You take the Orion, for example. Orion is launched by SLS. So you have the rocket. Basically, the rocket gets you out of out of gravity, more or less, and then you fly to the moon with another vehicle. So this is really what is space to space. And what we want to bring, which is new, is on the one hand the affordability. We target to be 25% of the competition for the low Earth orbit, so for the stations, 30% of the competition for the moon. So this is super important for us to be very affordable. We're going to be sustainable. Sustainable means we'll be probably the first company in the world using green propellant for the capsule or for a spacecraft. And our vehicle can be refueled and is reusable. We have 2 propulsion systems in the vehicle. One for the capsule, which is the part that comes back to Earth. And this we're going to use green propellant. So normally you use hydrogen, which is what, for example, SpaceX is doing with Cargo Dragon, Northrop Grumman is doing also. Most of the people in the space industry are using hydrogen. It's very efficient. The only problem is very, very toxic. And in the past 10 years, new technology has emerged. And the one we're going to use is H2O2, so hydrogen peroxide. We'll not be the first to use that, but the thrust of that, the thrusters that have been developed with the technology, normally it's quite low so far, and we're going to bring that to the next level with our partner so that we can have higher thrusters. So to be very precise, 24, where we do a subscale demonstration, we'll fly with 22 thrusters, green propellant, so that's not that huge, but then we target in 26 to fly with 300 to 600 Newton class green propellant thrusters, and that's a real innovation. So we believe that in the next coming years there'll be depot, and this depot most probably will be oxygen and methane because of the drive of SpaceX. So this new propulsive system that we are developing, it's an engine that is 15 kilonewton thrust, which is throttable, so that we can use it to land on the moon. It will be 3 engines, so that we have like flexibility in the way we land on the moon. And it will provide enough energy to go to lunar orbit. We will reuse also a bit like SpaceX they are doing with the Starship. The LOX methane for our reaction control system, so very small thrusters which are maintaining the attitude of the vehicle, both for the landing on the moon and for the rendezvous with the station. So that's what we have in plan.
Is it just one vehicle or?
Yeah, that's the whole point. And because, let's say, traditionally in the space industry, you would have one vehicle for one task. But if you look at the aviation industry, if you look at the car industry on Earth, it's very, very much like industrialized. And you're not going to, I mean, of course, like, a big car is different from a smaller car. But as much as possible, the industry tries to reuse the same brick and pieces for the varieties of cars and try to like leverage the synergies between the varieties of cars. And we believe that's exactly what's going to happen in the space industry. Well, if you look again at SpaceX and what they are doing with Starship, you have the cargo version, you have the crew version, and you have the refueling version. And we do a bit the same. So we use exactly the same bricks. And if you want to, so we have the low Earth orbit version and we have the lunar version. And the lunar version also has kind of 2 sub-versions. If you want to really land at lunar surface, you don't need to have pressurized payload because you want to bring like rovers, or you want to be able to have like an inflatable habitat on top of your vehicle, but you're not interested in bringing like food or etc. But if you want to go to lunar gateway, you want to bring food for the astronauts, for example. You want to bring pressurized stuff or things for experiments, right? So then you have the capsule.
Will you refuel it yourselves? So you're building a system for that as well?
Yes, so we have a version of the capsule, which is a version that can contain fuel. The capsule will have docking interface, right? We'll have also docking interface in our service module. So we can be like fully independent, but we believe also that there'll be step-by-step like tank stations, so that we will not need this full independency. But we plan already so that we have a concept of operation where we are fully independent, because at the end it's a kind of chicken and egg problem, and we don't want to depend for the tank station to arrive so that we can perform the mission, because then you're like completely dependent of what's going to happen in the market. We want to be able to perform the mission with all the technologies.
And so when it's up there and either you refuel it yourself or by someone else, for how long can it keep going? How many times can you reuse it?
Yeah, so if you mean just like staying in orbit, we want to be able to stay like minimum 5 years, which is quite long. And then it depends what you do, right? If you do many missions, you'll have to refuel many times. If you don't do that many missions, you don't have to refuel that many times. But yeah.
Yeah, but if you don't just think of it as the refueling, what is the life length of the capsule itself? Can it stay up there forever if you want to?
No. I mean, because you have radiations, etc. And the capsule is really thought for re-entering. That's really the role of the capsule. The capsule, the raison d'être of the capsule is basically to bring living stuff or pressurized stuff to stations. These stations can be to low Earth orbit, they can be to gateway, and then it's to re-enter. And when you re-enter, of course, the thermal protections, they get damaged. You have to replace them, and you have to do kind of a maintenance of the capsule, a health check. So we plan to be able to reuse the capsule 5 times. We want that, let's say, the maximum time of between when it's splashed down and then reused again, that we are here talking about 6 months approximately. But at the end, there are many things we just don't know and that we will learn on the way.
And the modules underneath?
Yes, exactly.
Are they also... can they stay for longer?
Yeah,
or can you keep them in space?
The idea is that, as I was saying, that you can keep the service module for like 5 years in space and you can refuel it. So you have like, I would say like your engine house that can be refueled, and you have your living house, which is containing the living cargo, and then comes back Earth, can be recharged, and then is brought up again.
Because, as you say, it's modular.
Yes.
So can you basically also put modules together to build a bigger structure?
Okay, that's a great question. So theoretically, this is something you can look at. And if you think like down the road, how to carry more stuff, that's of course something you want to have a look at. But again, it's not for tomorrow. We are very, very focused on making the first demonstration happening and making sure that, so this is for this year, and making sure that the 24 mission that we plan for October 24 with clients on board and a real big subscale demonstrator is also happening on time. And if we are successful, then we'll have time for more disruptive ideas.
But today, how big is it today?
So the spacecraft for what is called Nix Earth, which is a spacecraft for the low Earth orbit, it's about 7.6 tons, just to give you an order of magnitude. And the one for the moon is about 10 tons. The width, we spoke about the 4-meter diameters, capsule and the service module. We may enlarge a bit the service module for the moon because we want to have a center of gravity which is optimized for this longer trip. And the height is about 8 meters.
Who's your typical customer?
So on the one side is the agencies, so traditional public customers, etc. So we want to serve the European Space Agency, we want to serve NASA, etc. But then you have also a rise of private customers for the low Earth orbit. Moon is still going to be public customer for this decade. We'll see, I think, the starting of a private business, by the end of the decade, refueling industry, drilling industry, etc. But so for low Earth orbit, private customers, and we have already LOI signed with these kind of customers. They can be private stations that we're going to serve. Also, people willing to use us as a kind of mini private station. So these are luxury customers, these are entertainment customers, virtual reality customers. Basically, they're using our vehicle as a platform for advertisement, product placement. We also have industry customers who want to accelerate their research. I mean, you know that in microgravity, if you do pharma experiment on stem cells, potentially, you can increase the speed of your experiment. And we plan to fly 3 to, at the beginning, then 5 missions per year. So really have a regular schedule, and the price is very, very low. So we are an enabler to privatize, I would say, microgravity as an environment for private research. So that's super interesting. So the customer we have right now who signed LOIs, as I said, is on the one hand space agencies. That's going to be very stable business. And then entertainment, industrial research, and space.
So how often did you say you're gonna launch?
Yeah, so what we plan is, of course, to start with one first successful. Again, I mean, we need to be focused on having fast and first successes, and then we can scale. But what we plan for is to have as a minimum 3 missions per year in low Earth orbit, and then we think the routine will be around 5 missions per year in low Earth orbit, and the same amount for the moon. And if that's really small, actually, right? It's very conservative, because if you look at station today, the International Space Station, you have about between 10 to 15 missions, including cargo and humans. So if you say, okay, that's going to be multiplied by 3 to 4, right? You end up with 50 to 60 missions per year. So if you say, okay, I'm having 5, I think it's very conservative.
But you said your plans are to actually be able to carry people as well?
Yeah, longer down the road. So we've been part of the team, and myself, we have experience in working on human spaceflight, because we had the honor to work on the European Service Module, which is half of the Ariane vehicle, which bringing back people to the moon. So we know what it is, basically, and we know it's very hard. And if you start with humans, and you can look, at the time it took Virgin to fly, the time it took Blue Origin to fly, you have to do a lot of tests to prove your reliability. And this lot of tests means a lot of money and a lot of time until you can have your first revenues. So we are funded by VCs. I'm not going to explain to my investors, right? They'll have to wait statistically, 8 to 10 years, because this is what it took China, this is what it took SpaceX, this is what it took Virgin, this is what it took Blue Origin. So statistically, it takes you 8 to 10 years to fly humans. And I think if I'm going with a business plan, which is, okay, just give me 1 billion or 2 or 3 billion, and then wait 10 years, and then you'll see we'll have the first revenues. I'm not sure I'm able to convince a lot of people to give us money. So we start with cargo. because we can move faster. We start actually very fast with demonstrator, because then even if we would fail, it's not inverted comma a big deal. We can learn a lot, and starting with cargo, and SpaceX had the same path also. We can prove our reliability. So afterwards, we can reduce the amount of testing. Then we create trust, and when the time comes, then of course we'll be the one to fly humans. So we already have that in our design. So we make our design compatible with the possibility to fly humans tomorrow. So we're very we know where we're going to have the life support system. The 4-meter diameter is here so that we can carry 4 to 5 people in the capsule. But we don't start with humans for the reasons I just explained.
How did it start out, and how did you get this far this quickly?
Yeah, so it started very very simple. And we didn't see any project like that, honestly speaking, in Europe, and we were just worried. Also looking at the market opportunity, we said, okay, this can be funded by private investors because they're a real market. So they're real return investment, which is possible with all the growth of the space station as I just explained. So took our decision to leave. I personally took the decision in April, so officially left in April Airbus, and then so company was created in summer, so in July to be precise. And then why it went super fast, I think we had a group of co-founders who were known and respected by the space industry. So when you have very, very good technical people, then you attract very good technical people. That's number one reason. I think we've also had the chance to attract people because our mission speaks to the heart of many engineers in Europe. Our feeling, I am frustrated because I cannot unleash my talent. Many people want to work for exploration because that's an area which is it inspires, I think, all of us. And we've never done what we're doing, right, in Europe. So working on a thing which is not a first in its kind in the world, but a first in its kind in Europe, and that can really serve our European strategic needs, is something which is very motivating for many people. So we got now about 1,000 applications, people willing to work for us.
But where do you go to find talent? Where do you recruit?
So at the beginning, it was really our network. Very beginning of the company, I think you have two things which are three which are absolutely key. One is the vision and the mission of the company, but you need to have really the right people, and then you need to have money. Very basics, right? So, and if you are wrong about the very first people at the beginning, that's a huge spillover effect impact. So we started with people we trust. So basically, the people you have in the core team are people who've been working together. So far, we've not been working with headhunters because I don't know, but we've not seen for the time being again the added value, and also had lots of applications just coming in.
And is that from a technical side, or is it
both
marketing and design? And
we are hiring many technical for the time being because we just need to build the stuff. We're going to grow next year the sales team. That's going to be an important priority because we have the chance to have already as I was saying, 60% of capacity, which is pre-booked, but I want to grow the sales pipeline.
I want to take it back a little bit to your what you're actually doing here. Part of your goal is making space affordable and accessible. But what is affordable? What does it cost to send a kilogram to space with you?
Yeah, so we have to differentiate between 1 kilogram in orbit with the launcher, and then the additional space-to-space transportation service that we provide. So to compare what is comparable, today if you want to send 1 kilogram to space station, to the International Space Station, and then you want to have it back, so let's say the glass of water that we have in front of us, or this bottle of water, we send it to the space station, we want to have it back, you'll have to pay minimum $100,000. If you have no touching of any astronauts, if everything is automatized, this is $100,000. If you have an astronaut working 1 hour, because I know you want the bottle of water to be open and whatever kind of experiment inside, and then brought that back, this 1 hour of one astronaut is about $150,000 for 1 hour. So you see, it's way more than even the best paid lawyers in the US. So our target is to send 1 kilogram up and down for $25,000. So 25% of the current price, including, of course, the cost of launch and everything.
But there's not an option with the astronauts meddling with the water.
Honestly, the cost of an astronaut, like in the future, in the private space stations, I think this needs to be like seen in the ecosystem. I'm sure like Axiom and Orbital Reef and Space Lab, they have in the business plan, of course, you know what's going to cost. But I think we're just at the beginning of this growth of that. So I expect the price really the cost of an astronaut to decrease significantly. The launch costs are representing a significant portion of that price. So Starship is going to, again, bring the cost of launching down. So I'm not answering like directly your question, but we can be cheaper because, yes, we focus as a first step only on robotic experiments, but we're already the majority of the experience of space station. And we can be cheaper also because we reuse the vehicle. And we can be cheaper also because in space, a large portion of your cost are actually minds, so people. And on average, an aerospace engineer in Europe is like 1/3 or 40% of the price of one aerospace in the US. And these are just like statistics. So being based in Europe is a good advantage for us because you have the competence and it's cheap.
But what's your view on space debris? I mean, if you send something up to space, there's going to be a risk of...
Yeah. So I will have to then close. But so space debris is... So first is really focused for the time being on the low Earth orbit, but I see that as a huge risk. Well, let's say us as a vehicle, we are one vehicle, we are reusing our vehicle, refuel our vehicle. So, I mean, we don't contribute to create debris. We could even contribute with our propulsion technology to serve space debris removal vehicle or potentially ourselves, longer than the road to do that. Because at the end of the day, if you think about how the removal of the debris is going to be organized, well, you don't have that many solutions. You can try to do things from Earth, but, a lot of energy, not really working, and certainly not working for big stuff. You're not going to have like one vehicle and then it's launched, by a launcher and then it does its mission and then it's done. I mean, this is like crazy. It's like you have one vehicle per mission is going to cost a lot of money. So what you want to have is a fleet of vehicles which are staying here, which are based in the orbits, which are the highest risk orbit, and that can remove let's say not seconds, but like you give them a mission, you can plan the whole mission profile, and these vehicles that need to be refueled. As I was saying, you want to stay up there, and not that every mission you need to launch a new kind of chaser. So you want to have a chaser which, if it stays here, plus has a high level of energy, it has to be refueled. Cannot be different. I mean, so I think, the propulsion technology that we're developing can be like a very critical technology for the chaser. For the time being, we don't focus on that market, and there are other players, but we would be delighted to serve these players who've developed really like technology with robotic arms. We have also a rendezvous to non-cooperative targets that they can use basically our propulsion system, because I think that's going to be the key for a sustainable space debris force, if we call it like that.
The thing I like most about this technology is the versatility. You just need to decide if you want to put a research project, people, or a space debris vacuum cleaner out there, and the exploration company adjusts their vehicle to fit your needs.
And isn't it fascinating to think about how much knowledge and experience there is right here in our backyard in Europe? And the speed is unbelievable. I mean, at this point, Mars isn't looking that far away at all.
Give it a few years, and there's a definite yes following our title question. But not quite yet. More exciting space talk next time. My name is Susanna Levenhaupt.
My name is Marcus Pettersson.
The music we play is composed by Armin Pendek.
Have We Gone to Mars Yet is produced at Beppo by Rundfunk Media in collaboration with Rymdkapital. Read more about them and how you can get yourself involved at havewegone-to-marsyet.com.
Hallå? Programmet gjordes av Rundfunkmedia.